Hello and welcome back to Compiler Programming. Today we are going to work on the startup code or in startup initialization feature. I don't know how to call it correctly, but the idea is that sometimes you have code that needs to be initialized exactly once, and it needs to be initialized on the startup of the application. Now, so here's an example of that. So for example, we have write file function, and we are expected to pass a handle to the standard out. We know the index of that handle statically at compile time, but we don't have an actual handle itself that will come from operating system at runtime. So we are left with a couple of choices. Choice number one is to do what I'm doing here, where basically every time I want to call write file, I will call getStd handle and do like and let the operating system hopefully optimize it out. I think it keeps a handle cached somewhere, but we cannot be guaranteed, and it's like very specific to this thing anyway, and it would be nice if we didn't have to do it. The second option would be to do something that I'm not even sure Mass supports at the moment, but something like, what is the type of the handle that I'm using here? It's a 64. So it's a cached std out handle that is 0. And then I would say that if cached std out handle is 0, then I would try to make something like that. I'm not even sure that will work, honestly. It needs to be like this. Yeah, I have no idea if that will work because I have not tried to make global variables. That I have no idea what will happen here, to be honest. But at least it will illustrate the code, right? And then it goes like this. You can try to run it, but even if it doesn't work, that's not what I'm working on today, so I will not actually look into that. Yeah, so that causes some bad behavior and something I definitely need to fix later on, but that's kind of the point. So before, like if we want to call write file multiple times, now we would check if that handle is 0, and if it is, we will try to call a function and assign it to something better, and then use that cached one. That also has a problem that we are keeping this if in the function body. So every time we call a function, it will at least need to check that the cache is initialized. And I mean, modern processors have branch prediction, so it will be mostly predicted branch if the code outside of it is also not forcing too much eviction from branch prediction. But anyhow, so in the best case scenario, this is pretty fast and it's okay. But there could be scenarios where this is actually quite expensive. It also will be expensive on some architectures that don't have branch prediction, like all the ARMs. Better approach would be to somehow tell the compiler that this is, even ideally we would say that this is a constant from the standpoint of the rest of the program, but that we would like to initialize it at the startup time. So I would say something like startup, and I would pass it a block maybe. That would be, I think, the easiest thing to implement. I could also try to support it without the function, but it's just easier to do it with this. We can do on startup. I don't know. And that doesn't really matter. That's just backshading on the name. But the point is, we would say we would just do this. So now, and we can even move this code here. So now this code doesn't even know about the the index that we need to pass, so it's even better than it was before. And we now only do this once, but obviously we need some support from the compiler to actually run this code before the main runs in our application. And that's something we will work on. I will actually undo all of this stuff because firstly, I think we should maybe actually do fix this bug, because if we want to have this kind of global variable, we will need to have this working. So let's look at what is going on there and go from there. Okay, so let's try to run it. Okay, so what is happening here? Okay, so the thing is, it tries to reserve. Okay, that totally makes sense. So actually, this should be this in current semantics of the language, because we don't have constants anyway. That means that this will be just a global, and I think we can still write to it. But yeah, let's see if that's actually the case. Okay, so the problem here now is, oops, I hate that feature of the Windows. Need to disable it. That it treats this as literal, and that's, I guess that's the correct way maybe to handle if it's a declaration. So I would still need to think about semantics of this, but we can just explicitly cast it to NS64, and that should work just fine. Let's try that way. Okay, so that's not great. We are trying to move into immediate zero some kind of memory. Right. Okay, so okay, we do need to support this version. So what was happening here is we were saying that like when you do this kind of declaration, it's a compile time declaration. That means it tries to evaluate this at compile time. It gets compile time 0, and it stores it as an immediate, and then we try to write to immediate. We should catch it earlier than trying to actually execute the instruction, but for now that's fine. I will look at it later. So the option would be to actually implement this version. So let's go for it, and that would be statement or constant definitions, right? So we want something like this, but we would need to say token parse global variable, and it's gonna be roughly the same thing as the other one. I might figure out how to optimize this, but for now I'm just gonna copy paste. That's fine. And right, so we don't actually want this to be a lazy expression, but at the same time we do want to compile time evaluate it. So I think I will look for how we implement this stuff here, which deals with the assignment. Right. So let's actually do it like so, I think. Again, for now, I'll just do the copy paste version, and then once we get this to work, we can optimize, and I can do it off screen. Okay, so we have right hand side, right, and we're trying to parse the expression. That's not what actually we will be doing. Instead, we will be compile time eval. That's what we will try to do, because this is still a global, right? So we don't want to, if you put something like 42 plus 12, whatever, we want it to run to compile time, and only if it will have this special startup thing, right, that I talked about, only then we would want it to be run at runtime. I actually also forgot to mention there is an attribute in C++ for this. I saw it on one of the Andreas Kling Kling videos on SerenityOS. It was pretty nice. I wish I knew about this when I was writing C++. So yeah, now you know. You can also actually already have this. You just search for attribute constructor, and you can mark any function to be run at the startup, which is pretty neat. So this is not a new feature, anything completely out there. It's just implementing something that works in other languages. Okay, so we do compile time eval. Right, that's good. It will evaluate right hand side of our expression. The stuff here is okay. Yeah, we want that logic. I guess we want this logic as well. The only difference will be about the stack reservation, because it will not be on the stack. So value, we would say global value. Put this here, and this should not reserve stack. Instead, it should go to global. I think that's what we want. Yeah, we can pass the descriptor here, and it will give us the right thing, and we can refer back to it. That seems like what we want. We can say value global, context, what was it? And descriptor and source range. Okay, that seems perfectly reasonable. We would say function pointer and source range, RHS source range, right? Good, and we can do the same thing here. The only difference is we would say value source range. Oops, wrong place. Value source range, and here we would just do value descriptor. Assign is probably not what we want, because it will try to generate move instructions. So instead, and load address is wrong as well. So actually we will not support this code at all, because it will go into play with something that we will talk about later, which is relocations, and we don't support it at the moment. So right now, let's say panic to do implement when relocations are available. And in fact, the thing that I'm doing right now is going to be part of the implementation of relocations. So here we don't want to assign. Instead, we need to assert that value storage is where storage tag is storage tag static, and then we would want to copy that into the memory. I think I'm actually doing something like that in, maybe I am doing that in assign. Let me look, because I implemented it for the literals, but I'm not sure it will work correctly with what we are trying to do. So no, that works for the pointers, but we can definitely steal some code from this thing. Okay. Um, right. Um, hmm. I guess that is fine. So let's take this code and then go from there. Here actually I still need to say global value is 0, otherwise the compiler will be angry at me. Okay, so we will put this into RV data and byte size, okay, value descriptor, value descriptor. Okay, we allocate section memory, we get the label. Then we say that I guess I want to value init allocator allocate. Can I use the value make? I think I can, right? Yeah, I can, so that's fine. So I guess then I need to initialize it way down here. And the idea is, yeah, we allocate some storage inside of the read and write segment or section of the program. Terminology is a bit murky because it's slightly different in ELF and P32, I believe, but I will straighten it out later. Okay, so we allocate some memory in that section. We get the label to that memory. We get the pointer to the buffer that contains the section, and we will copy. We need to copy out the actual value there. Okay, that means that I need to say that global value is this. We have value make, that would be value descriptor, and target storage here is now this, right? And source range is value source range, that's fine. Okay, so we created the value. Now we just need to copy the memory in there, and the memory is well, we do need to have the assertion right here. Actually, we can move it assertion up. Right after we are done with the value, we can check that it's static, which it should be after we're done with compile time evaluation, but you never know. It's better to state these assumptions explicitly with assertions in the program, even if it is true at the moment when you're writing something like that. Okay, where was I? Right, this is not necessary. Assignment is not necessary. Now the memory, we will just say that storage static as C type. and I guess a value. Oh no, I don't think we need ampersand. Storage and C type. Actually, no, we don't want C type. We want to say storage static memory, something like that. Okay. And name. Yeah, it's now called symbol, or rather value as symbol name. Okay. What else? We don't have result value. Instead of it, we have value. Okay, and here we say RHS search range. Or actually, probably that is a better range for this value. Okay, so that at least builds. Let's try again to see what the test will reveal to us. Okay, we are crashing yet again. Let's see why is that. It is still the same thing. Because right. So here's what's happening. I merged together parsing of the global scope, so something like this, and parsing of blocks. Then I'm going through the same code, and that means I need to somehow distinguish whether we are at the top level or we are not. And I think the way I can do that is I can try to look at the context builder. So if context builder, or rather if not context builder, then I would say return context view unused result, unused payload. So we are forwarding like this. Okay, let's try to run that again. We still are not happy. So that probably is a bad way to figure that out. I mean, function builder is empty, so why did we get here? Because that is very confusing. I think that Visual Studio, as you can see, is very confused with this file. Does it like not reload it? Okay, let's just try to run from command line. Okay, so it's still crashing. But why is that crashing? Or because, yeah, because I put this code into the wrong place. It should be in here. We want to delegate to the other function, not that way. Okay. Well, we exited with code 0, but this only actually doesn't actually try to run hello world. It only passes the test. So in order to actually run hello world, we need to run it from command line, and we do have hello world. So that's amazing. That is the first part of this thing actually done. And now we are ready to proceed to the next one. But before we do, let me look at which episode are we on. I think it's 153 or something like that. Wow, that's a lot of stuff. I guess I did in between 151. So I think, yeah, it's 153. Okay. Minus m, episode 153. And what we did is we implement mutable global variables. That's nice. Now let's continue with our code, and we can try to implement our startup stuff. So there could be a couple of parts to it. The first is to parse and actually do something about this, and the second one will be with making sure that we run the startup code before we run main. So we need to switch the the entry point of the program from main to whatever is the synthetic function that will be generated by this startup, because we can have multiple of them, right? So we need to string all of them together, and then only then we call main. Okay. And the interesting thing about this is that we technically could also do it inside the function later on, maybe, where it would still point to the global memory, but we don't have a way to define a global memory, global variable inside of the function. So what I'm trying to say is, like, in C terms, you can say something like static foo or int foo is 0, and this is actually a global variable, but it is only accessible within this scope. And we don't have something like that right now, so we can't actually define it, but we would be able to do it anyway. So we now gonna put it like this. We're gonna put this here. We're gonna remove this stuff, and we will be ready to make that happen. Okay, so that is gonna be inside of C string, I suppose. Yeah. So these are our built-in sort of intrinsics. It also needs some refactoring later on, I guess. But let's not do it right about now. We would say startup, and it has arguments. It will. We don't actually want to match arguments, so let's do it. I guess let's put it here, and we would need to say token process. I actually need to rename all these functions. They were named token because they were dealing with tokens, but now they don't really, after I removed the concept of tokens from the program. As you can see in the last video where I did parts of that refactoring and I finished it afterwards. Okay, so token process or handle startup. Okay, startup code. Good. It will need to return a value. We don't need to really force it. Well, I guess. Yeah, that's fine to keep it that way. The whole force thing probably is not required in some places where it was required before because we were dealing with tokens, but again, not our problem at the moment. What we want to do is we need to implement the startup code, and it will actually be needing to work together with this code here. So let's see how we're gonna go about that. Token handle startup code, that would be um, return a value star. Okay. And what are we going to pass it? We're going to pass it a context and args token. That's fine. So execution context and value star args token. Right. Actually, we can take a look at how this function handles it, and that will help us, I guess. Okay, so it wants a parenthesis, and then it wants a group. Right. Essentially, we'll do exactly the same thing as here. And we'll go from there, I guess. So now we have return, I don't know, 0, I guess. Okay, so we have the layout block, but what we want to do with that layout block is essentially we want to treat it as a function. So maybe I will make my job slightly easier, and what I will do is I will just do it that way, because then I can use regular function parsing code to deal with this stuff, and I can hide it behind the macro if I really want to. That means I don't need to do any of that. Instead, I can say, well, really, um, hmm, I think I will not need this function. This is what I'm saying. Let's keep it for now, but I think I can do it in line because it is quite straightforward now. Where is our function parsing code? Come out wherever you are. Right. We don't actually need function parsing code. Instead, we want to parse it as an expression, I think. So let's try it that way. Value star startup function is token parse expression, and that would be context and args token. So it needs a view, so we'll say value as group args token children, and it needs a result. So actually this needs to be done slightly differently. Needs to be value any of context and range, and that range is args token range. Right, startup function, context, startup function. Right, something like that. And if this is not a startup function, or startup function descriptor, oops, I can't type today, tag. So if it is not a function, right, then that's wrong. Or if it is a function, function return types, return. So what is it? It's called returns descriptor. Okay, function returns descriptor tag is not descriptor. Actually, we can don't need a tag. We can do descriptor void. So we want a function that doesn't have a return type and that has no arguments. So that means that we also need another one of these to check for the arguments. And that would be arguments. Okay, so and or dynamic array length of arguments. Right, something like that. So in any of these cases, we need to say that startup expects a function as an argument. Okay. So that's type checking. Now we have a function. What do we need to do about that? Well, one thing that we need to do is we need to make sure that this function is actually compiled, and that is ensure compiled function body. Okay, so we just need to pass the context and the startup function to that. Okay, so we have a function, we compiled it, so it will be part of the executable. And the question is, what do we do next? Well, next we need to create a global value for that. And but that global value will actually be uninitialized. So we, unlike the code here, actually not here, was talking about code here that we just wrote. Unlike this code, we don't actually care about this part. So we could probably use value global for that. So we say value star global value. Actually, the type of this function should not be returned. It's only arguments that are supposed to be empty. For the function itself, we need to. It should have a value because that is what we will put there, right? Okay, so we need to create a global value. Do something like value global make, I think, or whatever that thing was. I will get back to it later. We can create a convenience variable here. So something like this. Context, descriptor, and source range is, well, that is the source range. Okay. Yeah, that actually creates a global value for us, I believe. So it is not make, it's just value global. And it is uninitialized, so we don't need to do the copying, but now we need to tell the that's quite interesting. So I believe I will need to assign it at the end of the day. There's some code that does that. Yeah. So something like this. Too few arguments. What do you want to have? Okay. Yeah, I know what it wants. The last argument is indicating what should be the end token of the expression, and this is used to differentiate statement versus expression parsing. But in our case, this is an expression, so this is perfectly fine. Okay, so that builds, but that is by far not all that we need to do, because if we try to run it right now, we will get a crash probably, because what's going to happen is this variable is going to have garbage in it, and if we try to use garbage as a handle, nothing good will come out of that. But still, let's try to run it. At least we should check if the compilation itself succeeds, because that also can be problematic. And it looks like it does not succeed, so let's try to debug that. Okay, we trying to divide by 0. Okay, so we get to here, and right. So I need to add a check actually that checks that descriptor is descriptor void. We need to say that startup function argument must return a value. So I think that should fix, at least catch the problem. for us. It did not. Interesting. So let's break here and actually run this code. So descriptor, it is descriptor void. Okay. So I guess we are crashing somewhere else. So we have a function that is a null pointer. Interesting. Oh, okay, yeah, I know what's going on. That's actually perfectly fine. That's a problem with the test because I think that's a problem with the test. Um, so I guess what happened was that we failed to compile main, and something like this should be better. So the test will not crash now, but there is still a question of why that failed. And try to make something like that. Maybe that will give us more information about it. Must return. Okay, yeah. I just added this thing, but then I didn't update the code to actually return some stuff. So now it will return this. Okay, so it expects a storage tag that is static, right? That was in the code that we wrote, and that's okay. So what we can do, I think, is say if value storage tag is storage. I think there is like storage is label of value storage. So essentially, all that we are doing here needs to be done if um, if the if the variable isn't already in a global storage, right? Which is what we are doing in that code to handle the function. So let's try like that. All right. Let's actually make it explicit. Like this, I think. Okay. That is an interesting error. What does it cost by? So our bounce check-in failed. We are trying to get a label that does not exist. Interesting. Right. I think I know what's going on. So Mm, that is kind of awkward. So I think this label belongs to compile time program instead of the runtime one. Right. Right. How are we gonna deal with that? Hmm. I think what I'm going to do is I'm going to change how all of this works and make it simpler to implement. So it will work like this now. It's slightly less elegant, and I might still implement the expression version of it. But with this code, we no longer force the this thing to be compile time executed, and instead it should be run as a part of the program. Okay, let's try it like that. Okay, yeah, now our test is wrong. Uh, we need to put that back. Okay, we don't need to return anything, so mm, I don't know. I guess we can do void value or something. Okay, that builds. Let's see. That should be not equals. Boolean conditions are always easy to get wrong. Okay, so now that's great. What happens is we are compiling the program successfully, but as I said, we now have 0 as a handle here. We try to call write file with a 0 handle, and I think it just does nothing in this case, which is fine. And now our job is to run this code at the entry. What do we need to do for that? Well, first we need to actually um, store this startup code somewhere. Uh, I guess let's go to value.h. We have compilation here, and we would need to have an array of some stuff. Um, do we need to have the whole function, or we can have just builders? Well, let's do whole functions. It's fine. We can say array value pointer uh, startup functions, and then we obviously need to create this thing. So that would be here. Oops, I don't need that slash. Startup function is dynamic array make of array value uh, pointer, and we would need to destroy it when we are done. Startup functions. Does it build? It does. Okay. So now we are ready to push it there. We actually don't need to do it here. I guess we can do it at the very end, but it's fine. How would that look like? Dynamic array push of context compilation startup function. Compilation startup functions. Forgot to put actual field there. Okay, so now we are gathering this up, and we need to put it in two places. We need to put it into P32 code, and we need to put it in the code for the JIT version. And I think for now I will only do P32, since that's a use case that we are dealing with, and I will figure out how to generalize or whatever afterwards. So, right. We. Source spec. We are looking up entry point main, but isn't the right executable doing that? Entry point. Okay, this is how it works. So we are looking for this function. Okay, that's fine. But we need to do a bit more. So we need to say bool has startup code full or dynamic array length of program. Actually, we don't need a program. We want context compilation startup functions. Or do we want it to be Boolean? I guess not necessarily. So here's the idea. We will create a new special set of function that would be used when we have any startup functions. I can also make it slightly worse by not checking this. So we always have this kind of trampoline code that jumps into an actual entry point that is defined by main from the code instead of doing it conditionally. And I guess that's the easier version. So that's what I'm going to do for now, because this video is already getting quite long. Okay, so we have these startup functions, and we need to create some code that would iterate over all of these functions, call all of them, and then call the actual entry point. And that would mean that we need to have another function that is specifically doing that. To do it well, we're going to say okay, let's just go for it. Function builder, or not even a function builder. Let me think about this for a second. At which point do I want to do it and how I want to do it? So we will need to call the function, right? So let's look at the function call, wait, function call, wrong file. Yeah, token handle function call. It gets the target and it gets args token and it will do a result value. Okay. We need to have a builder for that, which we can get, I guess. So let's start writing this code. We would iterate over all of the startup functions. We would get them as value star function, but that's a wrong array. We need this one. Okay, and we want to call it. Now the trouble with this will be, okay, so we need args token, okay, and result value is void value, and args token is slightly awkward, but it's fine. You can do, say, value star fake args is value make, so fake. I have a bunch of fake groups made in a bunch of places. Make fake body. Right. That sounds okay. We can take that code and group. So fake arguments is this. The only difference is this is parent and we actually don't have any children. Okay, so that should take care of us not having arguments. And now we just need to be inside of the function ourselves. Not necessarily, we just need a builder, I guess. So let's look at what function literal does. Okay, it allocates, fine, gets a descriptor, k, k, parses the arguments, and yeah, it doesn't actually do anything to the body, right? Because the actual thing happens inside of here. Inside of it is ensure compilation, right. So it gets to here, it looks at the body, does a bunch of stuff, checks if we already compiled this function, if we sets up the arguments, does a bunch of things about return values. Right. I think we don't care about any of that, to be honest, because we literally just need to make like call instructions. That's all we really want to do here. Should I just do that? I think that will work. So let's try this simplest option and we will figure out if that is not what we actually want. Call, right. So let's do it like this. We would have function builder. Star builder is okay. It's created inside of here, I assume. Function begin. No. Who creates the function builder? That's my real question right now. Function. So this is eval builder. That's slightly strange. Sure. Does this thing create a function builder? Right. It does. It does. So I guess we want to do the same. Let's separate this code somehow, I guess, so we can see the new stuff. And that is startup code. Make label. I'll call that label startup. Okay, that's fine. Function values, we don't really need that. That is like storage, whatever. The thing is, we will need the function stuff. That's not great. Okay, let's just continue as we are, and then I can figure out how to make it better. Or is it easier to just create the freaking function? I guess I could create a function and then fill it in. So function. So we do want a function literal. Function. Right. Value function value is value make context descriptor. We need storage. That would be actually we want storage none. Sort of no. We can put the storage. That's okay. Storage and source range. Yikes! We don't have one. So I guess that's what goes here. Right. Let's try to build this and see our 100 errors that we have. Body. Don't have one. Next. Scope. Don't have that either. Make label undefined. So what looks like to me is that we actually want to take that stuff and put it over here. and say value star or even void program init startup code. And that is the wrong file to do it in. Let's put it in here. Okay. Now we can pass execution context into here and see what else we need. That's fine. So program star program is context program. This needs to be a slice literal. This needs to be a star. Okay, can call it function. That's good. From value star to descriptor function. So we need to say descriptor function, something like that. Right. Okay. And then we can say function storage. We don't have instructions. That's because that would be builder instructions, I guess. Right, it is inside of code block. My brain is starting to slowly not want to do anything. Right, we don't have source range. So I will add the fix me, which is a general fix me that I have in multiple places. Create a special source range for internal values. Okay, so we have the call, and this part is not supposed to be here. Yeah, I think I accidentally grabbed it from here. Group. What? Okay. Fake args. Right. We are getting somewhere. And this call actually happens. So we don't need really any of that, because we can just do this thing directly. Right. This is not really used. Okay. We will need to use it because, so iterate all startup functions, and then we call the entry point. So there needs to be another one of these that is for the what was happening before. Program, yeah, entry point. Right, and this is actually a jump. We don't really want to return. I mean, it doesn't really matter if it is call or jump, but and we swap out the entry point. Okay, that is this code. We do need to forward declare it. So it's actually void, right? So that's program new startup code. Now we can call it from here. Right. There's one thing I forgot to do, I guess. No. Well, yes. That's kind of awkward. On one hand, we want this function to pass through this. On the other hand, uh, okay, so this is going to be heart surgery on this whole P32 code, so we'll probably spend next 2 hours debugging what's going on. But we are no longer going to try to do it this way. Instead, no, we are going to builder. Right, we need to find a builder that is matching this function. Oh, how are we going to do that? Sure. Yeah, that is very awkward indeed. So we go through this, and if builder function is, so this is basically the same array. Yeah, that's not great. I guess what we can do is we need to function code. Function code, what do you take? You take a builder and you take a layout. Or awkward, awkward, awkward. Okay, let's undo this slightly. And okay, what do I want to do? I want to encode this custom function that I just created. That means that in here I can return a function builder. Right, return builder. I can update the header as well. Now I will call this function function builder start startup builder is this. Okay, we have a builder. We don't need the if. Now we need to push a layout 2 plus 1. We will do this stuff. So here's our builder. We will pass that there. We will pass the layout. Well, now found entry point doesn't make sense because we always will find an entry point because we create it here. Right. And this check can actually move into here. Okay, how was that? That is a startup builder. That's no longer a thing that can happen. Okay, well, that builds. And the big question is, will that run? And I would say likelihood is very, very low that that's going to happen, but we never know. First, let's try to run the tests. Just output the executable, and even that fails. So we are trying to to encode the builder that is frozen. Actually, that is not frozen. Okay. Right. I think I need to call function end on this. Oh, I think I just need to manually adjust the frozenness of this instead. So I would say builder frozen true. Okay, let's try again. Still not happy. Descriptor byte size. Function encode. It is unhappy about return descriptor. Right. Well, we can fix that. We can say that explicitly you are returning a void value. Let's try again. Still unhappy about the same thing. What? From descriptor start the const char? What is happening? Okay. So I guess it needs to be like this. Right. Okay, so we actually compiled the executable, and now I'm gonna open up a second debugger specifically for that executable. because I want to look at the generated assembly and see what's going on there. If it launches at all. And it is completely broken, of course. Right. That's not great. Let's take another look here. So we encode all of these. We encode this one. I mean, looks fine to me, but I guess how are we gonna debug this? So debugging encoding of the executables is always not fun at all, but we can look at here. Let's step through this code. We create a function, we create a label, everything is fine. Okay, we create the function. There are no startup functions. Yeah, because there are no startup functions in the first executable. There are some here, I hope. Right. So we can look at builder, code block, instructions, data, items, and watch. So we have an assembly instruction that is name, call, operand, memory, memory location, label index 1. That's a bit suspect, I would say. Maybe not. I guess no, I guess it's fine. Okay. And then we put a jump. So that's I should be going to label index 2 or something like that. Indirect. No, it's even 4. Okay, it doesn't really matter. And that's perfectly fine. So here things are okay. As okay as they can be. We get the layout, we go into encode. It's not a macro, it's frozen. Out layout. Stack. Okay, we have this. We should not have any. I can run to here. This should be sub 0 because stack operand should be 0. Stack size operand. Where is stack size? Stack size, yeah, it is 0. Well, it is not useful, but it's shouldn't be harmful either. So we encode the instruction We can take a look at the buffer, I think. So buffer, memory, and we can actually put it here, and we would see what's going on. So we want actually something like this. It's very, very bad UI right there. Okay, so we're gonna be writing here, right? So this is our start, and we're gonna be writing here. That seems fine with what we're gonna write. So we wrote two instructions. Let's look at them. Well, these instructions seem that looks wrong, I guess. Actually, no, it's not fully encoded yet. Right, because we haven't actually resolved labels. Or did we? Where is a label resolution happening? No, it happens after we encode the text section, no? Yeah, it actually happens after we resolve all the sections, so that's okay that we have a really weird thing right here. Okay. I mean, that doesn't look very bad to me. This code doesn't really matter because we'll never get to here. So that seems all fine, to be honest, which is bad. So what is our RVA? Result entry point RVA is 4225. Is that even correct? Oh, I think the way I did it is not really gonna work out very well for anybody, because it skips a bunch of steps in between, and that might be problematic, I guess. How can we fix that without doing too much work? Let me think quickly about that. So, firstly, I guess let's start by getting rid of our changes because that's going to be a nightmare to try to fix them. No, I don't want to save this. So this code should still be in a state where, yeah, it just does nothing. And if we do again this, it will work just fine. The problem will be that So all of this works just fine because our entry point is at the right place. Right. How can we make this code less hacky? Well, I guess the way would be, so we don't call ensure ensure compile function value. So we don't call that function. Let's look again at what it does, and if we need to do anything with that. So it calls function end, but I don't think function end is very important, and it pushes the builder. Okay, so function end, normalize instruction appearance. Okay, we don't really need to call this. We can now. That's not really a problem. Well, let's call it. Or not. I do want to do the push now. Originally, I was thinking of not doing that, but now let's just do this, because that might be a better option overall. Void and void, and what we're gonna do is we're gonna call this before we do anything else. So we call this write executable, and right before anything, we'll just say any startup code. And we'll see where we go from there. Because now this is should be more or less a standard function, and all the previous logic should still be exactly as it is, but you never know. So let's do remove build, rebuild everything from scratch, and now go again into here, and let's try to step inside again. Yoo-hoo! That's actually what we want. Well, I don't know if the whole thing works, but at least this is our startup routine, so that's great. We go here, we go into the call, this does a bunch of stuff, which seems to not go terribly wrong. And then we jump to our actual main function. Okay, that is a problem, I think, because no, actually it's fine, because if this is 0, we don't actually touch the stack, so everything is fine. Cool. Well, let's let it run. It exits with the code 0, but did it blend or did it print the hello world? Okay, we don't need this anymore, I hope. Oh, look at that. We have startup functions. There's obviously a bunch of stuff that needs to be cleaned up, but this makes me very, very happy, because now I can do code like that. And as I mentioned in the middle of this code, that startup code will be necessary to implement something else that we need to do, but that's going to be left for another time. With that cliffhanger, I think it's time to wrap up. Thank you very much if you stuck with me through all this debugging, and hopefully see you next time.